Hi guys, welcome back. This is test 2B for CAD Assemblies. Before we assemble this bracket with the nut and key and the pin, we need to create all of these IPT parts. And so I've already created these two parts because they are fairly simple. So I'm sure everyone will be able to get that. These parts, however, I will run through them. This is a little bit tricky. This nut is fairly simple. We've covered it in the practice test as well, so it shouldn't be too difficult to do that. However, I will go through it. So let's start with that. So create a new sketch, and we can start with the biggest circle, which is diameter 22. Sorry, not diameter 22, this is diameter 19. And then we can extrude this a distance of 10, and then this is 8 by 1. And then we'll just create a new sketch on this side, another circle of 8 diameter and extrusion of 1 millimeter. And then again another sketch. This circle would be diameter 10 and a length of 29. Right, then we can add in our chamfers of 1 millimeter. So 1, 2, 3, as given over here. And then apply that, and then we can do our plane. So I'm gonna open this up, and then I'm gonna add another plane to this. So go to the bottom, there you go, and just hide this one, and this one should be a tangent like that. And then we can do our another sketch on this tangent plane. So we know that this is a slot of width 3, and it's a distance of 5 millimeters from this edge, and a total length between these two centers of 15 millimeters. So if we go back here, we can create a slot from there to there, and then we can just dimension everything. So this distance must be 3, this to there should be 5, and then from this center to this center should be 15. And then we can extrude this. We know that this is a total length of this diameter over here is 10 millimeters, and if this is 1.8, then we know that the depth of this should be, if the total length is 8.2, then the depth should be 1.8. So we can cut out a depth of 1.8. Just like that. And so there we have that part of it. We can now go to the back of this, and we can create another sketch over here. We can project geometry, and then we can just create a circle on this edge. That circle has a diameter of 6, and then we can use the circular feature. It should be 6 circles on this axis, just like that. And now we can extrude everything, or I'll cut out these parts. And we can cut through all, and we will have the key or the nut assembly or nut IPT created. So that is how you would create the nut IPT. Now we need to create this bracket over here. So we'll go back to and create a new IPT, and we can start our sketch. We can just create an L bracket and then start simplifying it from there. We can start adding all our extra features. So we know this entire distance should be 50, and this height should be 60. So we can create something like this, and then something, just cancel that, starting from this edge, create something like that. So we know that this thickness as well should be 7 millimeters, and this thickness as well should be 7 millimeters. And so let's just centralize everything once again. And now we can start dimensioning. So this should be 7, and this should be 7 as well. This entire length should be 50, and this entire length should be 60, something like that. Then we can extrude this in the direction, so this has a width of 40, so both of these will just be a width of 40. So if we extrude this, in both directions of 40 millimeters, so we have this part. We can then pick one of these planes to start working on, so that we can start with this part of the IPT. So I'm going to pick this one. This is a total of 45. The center point is at 45 millimeters above the surface. It's a circle of diameter 30, and it has a hole of 15 through. We also know that this is a width of 12. So we can extrude that. We can start off working on this surface. And we'll just place in a point in the center somewhere, and then just dimension this to the bottom as 45. Then we can put in our circle of diameter 30, just like that. And we can now put in lines from this edge straight up like that. And then we can just make these lines tangent to the circle. I forgot that we can actually also make the center point. We need to centralize the center point to the center of this rectangle. Then we can just trim up everything over here that's excess, like that. And then we can extrude and cut out at the same time. So this is an extrusion of this entire length is 12, and we have the thickness of 7, so this extrusion should be 5, and we can cut out those pieces over there. So this extrusion should be 5 millimeters, like that, and then we'll add, and this 2 pieces over here we'll cut away, like that. Then we can add a hole. Let's just go back. And we can add a hole to the center over here. It's a normal hole. This was a diameter of 15 millimeters. And so the top part is created. We can then go ahead to this part over here and create the same procedure to create this piece. Just going to rotate this like that. And if we look here, this is a diameter of 10 through. We have a slot of 3 millimeters in width, and we also know that this is centralized, so this entire thing is 20 millimeters and it has a height of 18. So this is 7, so we can take and this is 3, so we know this distance, we know this distance over here, we can figure out this distance over here, which should be 8. So okay, so we can project geometry on this, and then we can create a circle over here, something like that, and then we can just make this circle in line with this 2 pieces, just make sure it's in line, and then make this circle a tangent to this point and give it a dimension of 20. Perfect. And then we can make this 2 lines again on either side, and then just make these lines tangent to the circle as well. Then trim up whatever is excess, and we can extrude. So we're going to use this feature. So on top we know it needs to be a distance of 8, and in the bottom it will be the total distance, which is 10. Right, so in total we measuring from this plane, so this should be a distance of 8, and from here to this point should be 7 plus 3, which is 10. So that is how we get those dimensions. Then if we go back to the top and we click on these planes, then we can just cut all of this away, and there we have that part. Now we can create a circle here of 10, and then from here we can actually create this small little piece. This, if I zoom in a bit, this little tiny slot over here, which we know is a distance from here as 11.4, so this should be 1.4 depth and a width of 3. So what we can do is, if we zoom in here, we'll just create a small little rectangle, and then we'll just make sure this is in line with that, and then we can just dimension this to that point. Sorry. To this point over here as 11.4, and then this width as 3, and then we can extrude all of this. And so there we have that part created. So if we have a look, there we go. And now we just need to create the rib feature in between this. So we know it's a base of 20, a height of 20, a thickness of 7. It's in between all of this. It's in the mid of this plane. So we can just go to the origin, click on that, click visibility, and if we go to the side view, we'll just click that. Let's just cut this in half for now, and then project geometry on this and this, and then we can draw a line over here, something like that, and we will just dimension from this point to that point as 20, and this point to this point as 20. And if we have a look, they don't give us any angle, so I should extend this line a little bit until it reaches there, like that. And then we can just create the rib. So there should be a thickness of 7 on either side, and if we have a look there, that is the rib piece created. I can hide that work plane, and that is the total bracket complete. Okay, now we need to do the full assembly of this piece, or the support assembly fixture. So what we're going to do is, let's create a new assembly, and we're going to place this bracket as the grounded position. So this is what the assembly looks like. There's obviously a distance between these two. Okay, so there must be a horizontal constraint of a 15mm gap between the bracket and the shaft. So this gap over here should be 15mm. So let's start off by placing our bracket as our grounded position, like that, and then we can place our other IPTs, and then we can start constraining. So let's just go to the top view, like this. Alright, so the first part, the easiest thing to constrain would be this pin to that hole over there. So we can start by constraining that. So we click on the, until you see this arrow going straight through the middle of it, and then you do the same for that, and then we can just flip this around like that, and that should be this part constrained to the center of that. We need to constrain this piece such that it stays on there, so we can mate these two pieces using mate constraint. You can just click on this surface, on that surface over there, and then you click on this surface over here, and that will mate it. So this will be able to rotate in both directions like this. However, it won't be able to move up or down, or left or right, or back and forth. So it has 1 degree of rotation. The next thing we need to constrain is this pin, or this key, to this slot over here. So we can constrain this by taking this piece over here, the center of that semicircle, and constraining it to that part over there. And then we can do the same thing with this bottom piece over here, just like that. However, we want it to stay inside, so we can make these two pieces again by taking this inside part and this piece over here, and that should be mated together, just like that. Now we need to constrain this entire piece into the center of this hole. Obviously we know there needs to be a 15 millimeter gap, but before we get there, we can do that and just face it the other way, just like that. So we can slide this like that. We know also we want to constrain this piece such that it stays in there, so we can use an angle constraint like that, and then we can constrain it to this piece over here like that. So this will be 180, and you'll see it will stay in that direction. If we apply that and we try to move it, it can only move back and forth. Now we can constrain this piece over here to this piece over here. Now that's flush against each other with no gap, so all you need to do is put in 15, and the distance between that two pieces, between this piece, this bolt over here and the bracket, that gap is now 15 millimeters, and that should be the entire piece constrained.